In this lesson, I'm going to review the empirical rule and how it applies to normal distributions for Unit 7 of the Algebra 2 with Statistics course of study. So when I look at my big picture, I can see that Lesson 7.2 actually covers 4 days, but this particular lesson on empirical rule is going to be the second and third day. So students are going to get an introduction to the normal curve on the first part of this, and then they'll do a follow-up lesson after. In the scope and sequence, the standards that we're going to cover here are standard 23 and also standard 25. I've highlighted a few things that you may want to make note of, which is that we need to use technology for some of the summary statistics. And also on this part B, we need to estimate areas under the curve also using calculators. And in the follow-up video, I have instructions on how to use the TI-84 or Desmos. And then we also want to apply the empirical rule. So the question is, what is the empirical rule? So when you have a distribution that is approximately symmetric and mound-shaped, if it has certain properties, then it's considered approximately normal. Most people would refer to this as a bell-shaped curve. But even if you have a graphical display such as a histogram or a dot plot, you can tell whether or not it's modeled by this particular bell-shaped or normal curve. So the empirical rule actually states that if the mean is in the middle, which it would be for an approximately symmetric distribution, then about 68% of the observations will fall within one standard deviation. So remember, this sigma notation here means standard deviation. It also states that 95% of the observations fall within 2 standard deviations. So that's most of the curve. And then 99.7% of the observations fall within 3 standard deviations. So almost 100% of the curve is going to fall within 3 standard deviations of the mean. So for the lesson, it's going to start out on number 1. And it's going to give students a list of data. These are actually SAT math scores. And in number 1, they should be pretty successful because they will have seen the information in previous lessons. So they should be able to use technology to create a histogram. They could do it by hand as well. They want to describe the shape of the distribution. We're hoping it's approximately symmetric since the lesson is on normal distributions. And they can use technology to calculate the mean and standard deviation. And then finally on part D, they'll actually use the data and determine the percentages of the scores that are less than 1 standard deviation and also within 2 standard deviations of the mean. I want to work out number 2 on page 2 with you. And at the very top, you're going to see that it actually restates the empirical rule. So you have your 68%, 95% and 99.7% that will fall within 1, 2, and 3 standard deviations of the mean. So it does a good job of walking kids through what that rule actually is. On number 2, it says we're going to consider the distribution of defensive linemen in a professional football league. The mean weight for defensive linemen in the league is 284.6 pounds with a standard deviation of 5.3 pounds. And the distribution is approximately normal. So this is important so that we can actually apply the empirical rule. On part A, we're going to draw vertical lines on the sketch of the distribution showing the mean and standard deviation out to 3 plus or minus 3 standard deviations. We'll label the percent of the population within 1, 2, and 3 standard deviations. So we're not given the actual data here, or we're not given the mean per se, but I do want to write down that the mean mu is 284.6 and the standard deviation sigma is 5.3. So we're going to need to estimate about where the middle is. So I'm going to draw a vertical line and I'm going to label that 284.6. I would encourage your kids to label this number line as well. So in order to determine 1 standard deviation below the mean, I know that it needs to look kind of like the curve that I showed you above, but I can actually calculate what those numbers are. So if we subtract 1 standard deviation, we're going to get 279.3. If we add 1 standard deviation, that would be 1 standard deviation above, we're going to get the value 289.9. So we need to label those on the curve. So this is just the number line here. So 279, 79.3, and 289.9. Okay, so we know that based on the empirical rule that 68% of the data falls between those two values. Now, I would encourage your kids to go ahead and calculate each of the remaining values, but I went ahead and I'll show you the first calculation. If we subtract 2 standard deviations, so we'll be 2 standard deviations below the mean, we're going to get the number 274. That's going to be estimated about right here, 274. And if I add 2 standard deviations, I'm going to get the number 295.2. So I would encourage your kids to calculate each of those. And that's going to be about right here. So we know based on the empirical rule that approximately 95% fall between 274 and 295.2 pounds. And then the last 2 problems, or 2 parts rather, are 3 standard deviations below and above the mean. So 3 standard deviations below would be about 268.7 pounds. 268 right here. And my upper value, if I add 3 standard deviations, is going to be 300.5. That's approximately right here. So we know that 99.7% of all of the observations are going to fall between 268.7 and 300.5. Now, later in the lesson, I would encourage kids or you guys to show kids what each of the percentages are between each of these bars. So we'll get to that when we look at part D. Moving on to part B, we say, or the question says, about what percent of defensive linemen in the league weigh between 274 and 295.2 pounds? So what's great about this is we actually have these numbers on the previously calculated curve. I would have your kids redraw exactly what we're talking about. So this was 2 standard deviations below and 2 standard deviations above, and have them shade between those. So this shaded area here would be about 95%, and that is per the empirical rule. Part C, since the distribution of weights is symmetric, the mean and median are equal. What percent of the defensive linemen weigh less than the mean, 284.6? So if we support this with another drawing, we would mark 284.6, and we want to know the percent less than. So this actually is going to split the curve exactly in half. So that's going to end up being 50%. And we also know that 50% would be above that mean as well. Now on part D, we have about what percent of the defensive linemen weigh less than 279.3 pounds. Use the sketch to support your answer. So in this problem, we know that 279 is 1 standard deviation below the mean. So that's -1 sigma. If you wanted to write it as -1 standard deviation. And we're going to have to figure out the shaded area to the left of that. So what may be helpful is for you to go through each of the sections. And so I have the same values labeled for the curve, and actually ask kids to figure out what each of the percentages are between each of the vertical bars. So we know that if 68% is between 279.3 and 289.9, if I were to take half of 68, that's actually going to give me the left and the right-hand side of that. So if I take half of that number, I know that each of those sections is going to contain about 34% of all of the data observations. Now, that almost gets me, where that question is asking. But if I fill in all of these different sections, I should be able to very quickly get the answer to part D. Now, we know that 274 to 295.2 is 95%, but I also have to take into account the 68% that's already there. So if I take 95 minus 68 and take half of that, because I have I have 2 sections, then that's going to end up giving me 27/2 or 13.5. So I know that 13.5 is here and 13.5 is here. Now to check yourself, you can add 13.5, 34, 34, and 13.5. That should add up to be 95%. So if we repeat that for the next value, and I need to mark the third standard deviation above, which is 300.5. If we take 99.7 minus 95, and I take half of that, that's going to give me the section between either of the -3 and -2 standard deviations or the +2 and +3. So if I subtract those two numbers, I get 4.7. I have 2 sections, so half that. And each of those should be 2.35%. Again, if I add up all the numbers that we have written in, we should get 99.7. So the only thing that's remaining is anything beyond 99.7%. So that only leaves 2 sections. That's why I'm dividing by 2. And each of those are 0.3%. So if I take half of that, I'm going to get 0.15. So this last section is 0.15. Remember, that's a percentage. So that's very tiny percent. Now, again, if I add up all of the numbers that we've divided the curve into, I should get 100%. Now, if we go back to part D, it's asking us for the value or the percentage that's below that. So one way that we can calculate is to add up these 3 numbers right here. And if we add those together, we should get 16%. Now, some of your kids may think that's way too much work. Another way you could think about that is if I know the 1 standard deviation, if between these is 68%, I can take 100 and subtract that. That's going to give me 32. And then I know that half is here. The other half is here, which is going to give us the 16% that we just calculated. Okay, but this diagram can be useful for helping them determine other values, especially if you're maybe going to start from 274 and go all the way up to 300.5. It gives them a way to divide the curve. Now, moving on to the next page, we're going to look at part E, which says about what percent of defensive linemen in the league have a weight of 295.2 pounds. Fill in the sketch to support your answer. So we know that 295 was 2 standard deviations above the mean. So we can mark that. There's my 295.2. And it's asking us for the value above that. Okay, what percentage? So if we look at the diagram that we created before, we know that it's actually going to contain the 2.35 and the 0.15. So if I add this together, that should be 2.5%. Now, a second way to calculate that would be to take 100% minus 95. Since we know that 95% of the data fall within 2 standard deviations, that only leaves me with 5% left. If I take half of that, I know the lower half is 2.5% and the upper half is 2.5%, which is what we calculated. And then finally on part F, it says that Michael weighs 293.4 and we need to figure out at least blank percent and no more than blank percent of the defensive linemen in this league weigh less than Michael. So by having this diagram, again, this is going to help us determine the answer to part F. So we're going to notice that 293.4 is not on the labeled 1, 2, or 3 standard deviations above or below the mean. I'm going to put in my 300.5. But we do know that it falls somewhere in between 2 and 3 standard deviations above the mean. So this is approximately where Michael's weight is. So we don't know how many data values are exactly in here, but if I wanted to answer the at least part, I could add up 0.15, 2.35, 13.5, 34, 34, and 13.5. And if we add all of those, we know that he is at least heavier or weighs more than all of those people. So this is almost like calculating a percentile. So if we do add up all of those numbers, we're going to get 84%. Now, again, we don't know how many people weigh exactly that or above that, but we know that he also is no more than blank percent of the defensive linemen. So if I look at what is left of the curve, we've already added up, excuse me, we did not add this. If we added all of these up, that's going to give us 84%. Okay, we didn't add this one. So I'm not really sure how many data values are in here, but I do know that he's not going to exceed 295.2. So if I take the 2.5% that's remaining above that, that's going to give me 97.5. So we added up for the 84, the 0.15, 2.35, 13.5, 34, and 34. And for the 97.5, we took 100 minus the 2.5% to get that number. Now, we're not required to teach Z-scores for the course of study, so I would not do part G, H, or I with your students. But if you'll tune into the next video, I'll show you how to use technology to complete J, K, and L, because they cannot be done with the empirical rule.